Here we look at some less common ways to dimension radii that you might encounter in your work, beginning with very large radii. So here are some really big arcs. These happen to be in building shapes, but you might have a large machine, space shuttle that you're designing. And if you put this thing into a viewport on your sheet, the center line for this arc is going to be far away. So you are not going to be able to dimension this thing on a piece of paper unless you shrink it down to a teeny tiny scale, which is not very practical. So what do? ASME gives us this solution. When you have a really big radius, you draw the radius to scale with the center point where it's supposed to be, but then when you dimension the arc, you use a zigzag shape in your leader line and a zigzag shape in your dimension, which locates the center point. So you show the center point of the arc as if it's squished up, as if somebody, put a hand on the top and bottom of your drawing and squeezed it down. And you represent the fact that that is not the true location by putting these zigzags in here. Notice that the leader line, the dimension line which touches the arc, would actually point towards the true center if you extended it with a piece of with a pencil and a really long ruler. But then the other segment is drawn by using the offset command, offset from the dimension line over to the elbow next door. ASME gives us a number of other ways we can locate an arc, a part of a circle, and I'll just go through some of these here. You might use, if it's a big one, you might locate the center mark. There are a few cases where that's important. You might locate where the thing is tangent. Sometimes you need to tell them, here's where the corner would be. If it were a sharp corner and you did not put a fillet on there, here's where it would be. This is from, these examples are from Bruce Wilson, who's on the ASME committee. Now, one thing to think about when you're dimensioning is, am I giving them a dimension that's floating out in space where they cannot hook a tape measure? And this example on the left, which this is from a different drafting textbook, and this author has labeled this poor because it's floating out in space. This one is labeled better because here is where the fabricator could actually hook their tape measure and measure the start of the thing. I will just say that if the shop is using CNC, computer numerical control software, on computerized machinery, then they might prefer the example on the left. Their code in their CNC machine might like to locate where the center point is. So what you need to do is go talk to your shop and find out which method do they actually prefer before you put it on your drawing. Now, what if you have a curve that is not circular? Well, there are a couple of things you could do. One, and this is from ASME again, you could go over and up for several points on the curve. They're giving the x coordinate and the y coordinate and a little point function, a little plus sign, showing this is where I'm locating this point. And then the shop will have a way of connecting those points onto a smooth curve. Or you could give those same x and y coordinates in a table. Some shops prefer that. you can do a thing where you locate where these curves are tangent to each other. And notice that in